Good morning. Welcome to the session on data mining concepts and techniques. And in the earlier session, we have been looking into data cleaning. And we saw to mine some effective knowledge out of data, we need to use clean data inputs, or in the sense, the data that we give as input to the data mining algorithm must be free of errors. And we have seen that the process of removing this error is called as data cleaning. We saw some of the important reasons for unclean data. The first one is when there is incompleteness in data, it becomes unclean. Then you can also have noisy data. Noisy data is where there are errors or outliers contained in the data. Both these categories give the data, add uncleanliness to the data. And the third one is inconsistency in data. Inconsistency is where the data is mentioned as X in one table and the same information is given as Y, a different value in another table. So you have multiple coordinating tables in the database. Each of these database values do not stay consistent with each other. Such is also a form of error. So we need to identify that error and clear the inconsistency to make the data clean. And apart from these, there are errors that are intentionally generated. For example, because we do not have data in hand, we put some value there. Or people want to change some data and they overwrite existing data. All these are intentional errors that occur in the database. All of these methods cause uncleanliness in data. When we have uncleanliness, this uncleanliness has to be removed. We have seen that the methods for removing uncleanliness in data has to have a clear idea of why the error actually occurred. Once we know why the error occurred or how the error occurred, it is easier to rectify the error. So we have seen the first as incomplete or missing value data, and we saw that the main reasons for what are the main reasons we have for incompleteness in data. Then we looked into certain methods of how to add some value to that missing field so that the data becomes complete. You can either ignore the tuple, or you can manually fill it with the value, or you can use automated methods for filling in that empty value by using either a constant or an arithmetic mean, or you divide them into different classes and then find the mean. But the most effective way is to find the most probable value and fill that empty space with the most probable value. This can be done by using Bayesian formulas and decision trees. And we have also seen that there is noise in the data. Noise means incorrectness or errors in the data. We have seen some of the major reasons for errors in noise. Then we have seen some methods for correction of noise. The first one is binning, where you divide the data into equal partition bins and smooth out the values based on the bin values of, or the values which are present part of the bin. And then we looked into regression. I said we will look into regression in the further session. Today's session we are going to look more on to regression and clustering. Now, apart from data cleaning, the next, once the data is clean and available for processing, I imagine I have got multiple DMart stores, one at Kompally, one at Sanat Nagar, etc. etc. Now, when DMart wants to take a business decision on coming up with some strategy for improving their business, it is not sufficient for them to just look into the store at Kompally. So they need to integrate different aspects of that, put it into one warehouse before they even start processing or start making decision on that data. So that aspect is called as data integration. When data is to be integrated, it means it should combine data from multiple sources into one coherent place. So the software that is used for billing at Kompally and the software that is used at Sanat Nagar may be the same. So it is easier to combine data when you use a singular software across all your stores. But there are certain aspects of data which is not maintained that way. Example, the procurement of things can be done in a different ledger based methodology at Kompally, and they may have some tally based software at Sanat Nagar. So the same organization might use multiple forms of data for multiple perspectives. In that case, when the store tries to identify how to integrate these data, they should also identify methods that can integrate multiple forms of data. So it's not just the database, it can be from a ledger, it can be from a voucher book, it can be from a signed logbook. So there are different forms. It can be a voice recording, it can be the surveillance recording, so it can be video, or it can be text, or it can be in pen and paper. So there are multiple ways in which this data is available. So all of this data requires integration. Before we start integrating data, we are going to look into the types of data that are available, and the integration methodology is going to differ from type to type. Now we have seen that the data is a data means it is a raw qualitative or quantitative figure that explains a data object. A data object is something that exists in the real world. So if I say a biscuit packet, it is a real world data object or an entity. It can be described using multiple features or attributes. Those are called as data values. So, the features that explain or describe the data object is called as an attribute. In a database, we see the rows indicate different data objects, and the different columns in the database, they identify the attributes of those data objects. Just like how in a student database, every row is unique for a particular student. So a particular student with the roll number 15BK 1A0503 is a student, and it represents one single data object. And for that particular student, you will have a value name or a description about that data object, could be in the form of name, address, phone number, etc. etc. All of these are attributes of the data object. So a database of different rows and columns indicate data objects on every row or tuple, and attributes that describe the data object in columns. Now, our attributes are also called as dimensions or features or variables of the data object. The types the attributes can be are nominal, it can be nominal, binary, it can be numeric. In numeric, there are two different types of numeric attributes. We are going to see all these types one by one. The first one is a nominal attribute. The nominal attribute is where you have a set of values. It can be a set of strings or it can be a set of numbers, but the value the attribute takes is constrained to a given set. Now the hair color can be considered as a nominal attribute. It means it can take the value black, brown, gray, red, white. Only these values it can take. It cannot take any value out of this set, right? So if I say a student and its department, the department is a nominal variable. He can only take values CSE, ECE, triple E, mechanical or civil. He cannot take any other value as far as spec is concerned. Okay, so such a variable is called as nominal variable. A binary variable is where the value of that variable can either be true or false. Student pass or fail. That is called as a binary variable. A binary variable, it can be either present or absent such values. These are binary, or it can take only two values, true or false. For a symmetric binary variable, both the outcomes are equally important. Example is the gender of the student, where both male and female have the same. I don't differentiate anything between a boy and a girl student. So that they mean the same or they have the equal ranking. Whereas when the student is pass or fail, pass has higher value and fail has a lower value. Present or absent. Present has a higher value and absent has a lower value. So I have that is called as an asymmetric binary variable or a binary attribute. There are certain values which are called as ordinal. Ordinal are also like nominal values, which means they can only take values from a predefined set. But in nominal values, if I take the hair color, all the hair colors have equal value. Be it black or white or brown, all of them have equal value. They do not have any preference in the value that is taken by the data object. Whereas in an ordinal value, there is an inherent or a meaningful ranking order in the given set. For example, I can say the size of the t-shirt, it's small, medium, large, etc. Grades of the student, A, B, C, all of them are also nominal variables that are constrained to take values from a given set, but they have an inherent ranking order. Such variables are called as ordinal variables. Then you have different types of numeric values. The first one is called as a interval scaled value, which means all the values that have there are integer or real valued and they are measured in equal sized units. Such a variable is called as interval scaled variables, which means the if you say the calendar dates, they have values have some order, they don't have a 0 point at all. They'll keep repeating and repeating and repeating. All of them only have an order, but they do not have a value. In ratio scaled, there is a 0 point and values are distributed around the 0 point. They are also equal scale, they are also on scale. So such a variable is called as ratio scaled variable. Most of the real world marks, all of these come under the ratio scale variable. And let me not talk about discrete and continuous. These are types in the ratio scaled variable. Discrete is where you confine to a predefined set of values. Example, the pin codes of different states. That is a discrete variable which is also numeric in nature. Then you have continuous real valued numbers like height, weight, all of these are continuous attributes. So all of them come under ratio scaled only. Now, in data integration, when I try to integrate data, I have to first integrate the schema or the architecture of the database, and then I have to do some entity based integration, which means for the same student, if I've got different descriptions or different information in different tables, I need to bring them together and put it so that it represents the single student. That is called as entity based integration. And then when I'm trying to integrate data, the volume of data becomes very, very huge. When the volume of data becomes huge, it becomes very difficult for the data mining algorithms to handle. So we need to identify methods that can remove the redundancy in data and to reduce the data in size. So we will not be, as you don't have the data integration part of your syllabus, we'll not look into data integration. We will directly move on into data reduction. Data reduction is available in your curriculum. When I say data reduction, it means I have to reduce the data either in volume or in its representation or the memory it uses or the number of attribute it uses. So there are different forms of data reduction. We are going to see these types of data reduction. Data reduction means it is to obtain a reduced representation of the data set that is much smaller in volume but yet produces the same or almost same analytical results. So if I say data reduction, if I remove the mark statement of the student and then try to analyze the performance of the student, it wouldn't make sense. So I cannot just like that remove any attribute. I have to find methods in which I can effectively represent that nature without using so much volume. So that is called as data reduction. So which is why I say it should produce the same analytical result but with a reduced representation. Now why should we use data reduction? It is very obvious. We should reduce the data volume because only then our data mining algorithm will work effectively. Our data mining algorithm needs to work effectively. So that can be done only if we use less space, or the space consumption, if it raises, the algorithm slows down. And not only does the algorithm slow down, but it can also lead to erroneous outputs. In the sense, if I have some data which is irrelevant to the task that I'm working on, imagine I have the task of identifying the student performance in university examinations. Then, if I use the students' marks in the internal examination or the previous university examinations, it will be good. But if I start using the gender of the student, if I still have to have the address of the student, all these attributes are not required for analysis at that point of time. So I can remove such attributes that are not relevant to the task that I am performing, so that you can get a reduced representation, and on that reduced representation you can run your data mining algorithms. There are different strategies for data reduction. The first one is called as dimensionality reduction. In dimensionality reduction, the unimportant attributes are removed. We have seen what wavelet transform is, and we have also seen a glimpse of principal component analysis. The further things that we need to look in are feature subset selection and feature creation. We will be looking into these methods in today's session. And we have seen, this is what we have seen. So in wavelet transform, there are two different types of wavelets that are used: Haar wavelet and Dovizio's wavelet. And wavelet transform produces the frequency of a particular event, and based on the frequency we use less number of features to explain the same happening. Now we have seen a Hundi example for this, if you remember. So from the first thing to the second thing and to the third thing, we can see the third representation in the frequency domain consumes less number of values to represent the same information. So wavelet can be used for representing of our events or our data in the frequency domain. And we have seen what principal component analysis is. In principal component analysis, the data is represented as a matrix, a covariance matrix, and we find the eigenvectors of this matrix. You would have learnt in your previous statistical papers what the eigenvectors represent. These eigenvectors represent the basic or the inherent nature of the data. So that is where we use eigenvectors for analysis of data. So for multiple attributes, the eigenvectors will provide the principal components of the data. Instead of using the entire data, we can use only the principal components, but we will still have the same quality of analytical results. Now we are going into attribute selection. When I try to do attribute selection, it means I have to identify one attribute and see whether that attribute is required for analysis or not. In the case of the student marks, I can say when I'm trying to analyze the performance of the student, the marks data is highly important. It is essential for analysis. So that I consider as important data. Whereas there are data values which might not carry the same importance. Or I can say there are internal test marks available. When I have internal test marks, the total out of 25 is sufficient. I need not break it up into four different attributes, one for objective, one for descriptive, one for assignment. All this breakup need not be provided. I can consider that as one particular data attribute. Such variables which represent the same thing are called as redundant attributes. Now, if I say the marks of the first mid is available and there are two other attributes for representing the descriptive marks and the objective marks separately, then the data attribute that has the first mid mark is redundant with the other two attributes. So the redundant attributes may be removed from the database before data mining. So to identify redundant attributes, we are going to use methods called as correlation analysis and covariance analysis. When I say what is correlation in the first place? Correlation is the measure which explains how two different attributes are strongly connected to each other. Or I can say, if I know the value of one attribute, is it possible for me to identify or find out the value of the other attribute? If I can find out if there is some dependency between these two attributes that help me find unknown values, then I say that these attributes are correlated to each other. So if the attributes are correlated, they are going to be redundant. I can remove one of them and use only one of the correlated attributes for my data mining process. So the next is, how do we identify redundancy? The first methodology we use is a scatter plot. Scatter plot is used only for bivariate data, or I can use a scatter plot to plot the values of two data attributes. So I can use a pair of data attributes and plot their values. Now in this scatter plot, I see that the unit price varies from 0 to $140. And on the y-axis, I see the number of items sold. When I look into that plot, I see the number of items purchased increases from $40 to $80, And after the price is, when I see that the price is over $80, the number of items sold comes down to lesser value. So this is called as some correlation. So there is some dependency between the price of the object and the number of items sold for that particular object. So this means there is some correlation between the two data attributes. Now these are different forms of correlation. The first one is called as, the first one on the top left is called as positive correlation, which means as one value increases, the other value also increases. That is called as positive correlation. You can also have a negative correlation, which is shown on the right side top value. It means as one value increases, the other value decreases. Can you give me examples for positive correlation and negative correlation? We as faculty, we would say as the attendance increases, the marks if you will score in your final examination will also increase. So we assume that it is a positive correlation. But students think as if the less number of classes they attend, the more marks they will receive. That is called as negative correlation, which is not quite so. And the next one is called as the next one is the one that is shown on the left below area, is also a correlation, but it is positive until the value increases for some time, and then it becomes a negative correlation. The earlier example we have seen is such a correlation. So you have a trend in the relativity of the two variables. These are examples of uncorrelated data. When I try to plot the address of the student and the attendance of the student, there is literally nothing that is connected to these two attributes. So I can say that they are uncorrelated. When we try to plot uncorrelated data, this is how they will look like. So when I identify the correlation between two data, when I see that the data is correlated, I can remove one of that and then reduce my data. The most common correlation analysis method that is used is called as the chi-square test. The chi-square test is a statistical methodology to identify how much dependency is available between two different variables. If I do the chi-square test, you get a value called as the chi value, and if the chi value is very less, then it means that the data is correlated. If the chi-square statistic is very large, then they are not correlated to each other. So here is an example. You will not be asked to explain chi-square test, or you will not be asked to solve to find out the correlation between two different attributes, but you can just know what correlation analysis is. So in that aspect, this is a table, and for the table I can find out the observation, the difference between the observed and the expected value. Why is this calculated? When I say they are correlated, I assume that given the value of one attribute, I can identify or calculate or expect the value of the other attribute. That is called as correlation. So if I am able to expect a value, and if the observed value is very close to what I have expected, then they are highly correlated. So the difference between the observed value and the value that I am trying to expect because of the correlation, if the difference is very less, then it means they are highly correlated. So here is a example program of calculating chi-square. You might have already calculated the chi-square value in your previous things, and you compare it with the degrees of freedom alpha and look into the chi-square table to find out what the significance level is from which we get this value. The larger the chi-square value, the more they are related, and it's less, they are related less. And another form of correlation analysis is called as the Pearson coefficient. The Pearson coefficient is used when two different attributes have to be judged, and these are for numeric attributes. When you have numeric attributes, you can use the Pearson coefficient. These are plots that explain the correlation between two different data. Based on the correlation, we can identify redundancy between data attributes and we can remove one of the data attribute. Covariance is for numeric attributes. Okay. Now we have just had an idea of what feature subset selection is. We are going to identify all the non-redundant attributes of a data sample and only use those attributes for further data mining process, that is called as feature subset selection. We will then in the next session look into different numerosity reduction methods which can help us with some data reduction. With this, I close here for today's session. Thank you one and all. Stay home, stay safe. Looking forward to seeing you all soon. Thank you.